Hello, in today's video we're going to be talking about the AZX notation. Now this is a notation that chemists can use in order to identify certain properties of a specific atom or element found on the periodic table. So let's go through and identify what each of these letters means, and then since we're chemists through OU, we're going to actually be adding a different value to that. We're going to add a fourth variable here in order for us to solve and get the total understanding of this atom. So let's write this out. We know that the X is the big number, the A is up here, the Z is in the bottom left, and unlike what's written in your textbook, as chemists through OU, we're also going to put a C in the upper right-hand corner. Now let's identify what each of these variables are and then assign the AZX notation for a given atom. So let's first write out the X. This is called your atomic symbol. This is found on the periodic table. So I'm going to write out where each of these symbols are found or how to calculate them, and then we're going to go to a very specific example. We're going to be doing a lot of these tomorrow in class, so don't worry if this is going very quickly. So the atomic symbol is found on the periodic table. If you open up your textbook, on the front cover, there's a copy of the periodic table, and you'll notice that there's a lot of different letters in each of the little boxes. Those letters are your atomic symbol, and they're unique to each individual element. So if I'm talking about oxygen, and you'll come to find out, oxygen has the atomic symbol of O, hydrogen has the atomic symbol of H, helium, He. Now I don't want you to go around memorizing the periodic table because I always give you a copy of that on the exam or the quizzes, and you will always have a copy of it for your homework. So there's no reason to go around memorizing the periodic table. You're going to memorize certain aspects of it because you're going to be dealing with it so often, but I'm not going to quiz you on memorizing the periodic table. So this is your atomic symbol. It's found on the periodic table. It doesn't have an equation associated with solving for it. Z is called your atomic number. This is also equal to the number of protons of a given atom. This is also found on the periodic table. So if you look at the periodic table, you see the atomic symbol. The number underneath that atomic symbol for the first element, hydrogen, will be a 1. For helium, it'll be a 2. That equals the number of protons for each of those atoms, and it's unique to each individual element. So oxygen will always have 8 protons. Carbon will always have 6 protons. Hydrogen will always have 1 proton. You don't have to calculate anything. It's given directly on the periodic table. Let's go to A. This is called your mass number. Do not confuse this with the atomic mass. The mass number is not found on the periodic table. It has to be calculated, or is given to you. You can never just read it off the periodic table. The number on the periodic table that a lot of people confuse this with is the atomic mass. Do not use that number when dealing with the mass number. The equation for this, the mass number is going to be equal to the number of protons plus the number of neutrons. The last and final one that's unique to OU is the charge. This is just going to be the charge. This is going to be calculated or given in the problem. It also has a very unique equation that's associated with it. The charge is equal to the number of protons minus the number of electrons. These two equations are not given in your textbook, but I recommend understanding and memorizing what those are. I won't give you a copy of those on the exam or quiz. So the mass number is the number of protons plus the number of neutrons. The charge is equal to the number of protons minus the number of electrons. Let's do this for a specific example. Let's write out the AZX notation for neutral chlorine 35. And the way I said that, chlorine 35, was very specific. I said it was neutral. The neutral has to deal with the charge. The chlorine is the element that we're taking a look at, and the 35 is actually the mass number. So all of the information about the charge and about the mass number was given in the problem. Let's write out the AZX notation for neutral chlorine 35. We know that the atomic symbol for chlorine is Cl. We know that we found that by looking at the periodic table. The number under Cl on the periodic table is 17. That will be the number of protons. The mass number is this 35. It was given in the problem. And then the charge, since I said this was neutral, there can't be a charge associated with this atom, so it has to be a 0. If this was anything other than a 0, this wouldn't be called an atom, it would be called an ion. So now, from this AZX notation, pretty simple to do, let's calculate the number of protons, neutrons, and electrons that are present in this atom. So the number of protons is going to be given in the bottom left-hand corner of the AZX notation. That's your atomic number. Let's do the number of neutrons. Well, we had an equation that I erased that calculated the mass number using the number of protons and number of neutrons. So we can rearrange that equation to give you the mass number minus the number of protons equals the number of neutrons. So I put in 35 minus 17 gives you 18. That tells us that we have 18 neutrons in a neutral chlorine-35 atom. Let's do the same thing for the number of electrons. I gave you the equation for that. I'm going to rearrange that, and it says the charge minus the number of protons divided by -1 will tell us the number of electrons. So if I write that in there, we have 0 charge. We're going to subtract 17 from that. That's the number of protons. The -1 comes out of the equation. It doesn't have anything to do with the periodic table. And what we end up getting is 17. So what this shows us is we have 17 protons, 18 neutrons, and 17 electrons for a neutral chlorine-35. And with that, we're going to be dealing with a lot of these types of problems tomorrow in class, and I will see you all in class tomorrow.